Now, a system of equations has a point or an xy coordinate, such as this one, that works for both equations. So you have one equation, equation A. You have a second equation, equation B. And the solution is the point in the coordinate plane where these two lines cross. But for a system of inequalities, it is different. A system of inequalities has a region of points that can work for both inequalities. So let's say instead of equation A and equation B, we had inequality A and inequality B. Remember, for inequalities, you have greater than or less than, as well as greater than or equal to, and less than or equal to. For less than or greater than, instead of a line, you'll have a dotted line, because the points above or beneath that line will represent these solutions, but the line itself will not be included. If it is less than or equal to, or greater than or equal to, you'll use a solid line to represent that the points on that line are included in the solution set. Now, for an inequality, when you have greater than, the points above that line are the solution to that inequality. When you have less than, it is the points beneath that line. So this shaded region here represents greater than inequality A. And this shaded region here beneath inequality B represents the solutions for less than inequality B. Now, where these two areas overlap would be the area of solutions. The area of solutions for a system of inequalities is the overlap of the two individual systems. So the points above inequality A and the points below inequality B intersect here in this darker red pink region. So that would represent the area of solutions to this system. Now this coordinate plane stops here, but the solutions would continue in this direction. The area of solutions is considered open or unbounded if there are an infinite number of solutions. So since these points continue in this direction, in the positive x direction, then this system is considered open or unbounded. So in this section of the chapter, we'll walk through an example and complete a few practice questions for open or unbounded systems. And then to wrap up the chapter in the next section, we'll have a look at bounded systems. Now, there will be some cases in which you will not have any solutions. If the solutions of the inequalities do not have overlapping regions, then the system will not have any solutions. So let's say you had some inequality A, and the solutions were greater than this line, then these points would represent the solutions. And for inequality B, if the solutions were less than this point, these points would represent the solution to inequality B. So since these two regions do not overlap, the system for the two inequalities will not have any solutions. Remember, these solutions are the overlapping area between the two inequalities. But if the areas do not overlap each other, then there are no solutions. Now, as you're going through the process of using the substitution and elimination methods to find the area of solutions for a system of inequalities, you may encounter a false statement. Just like a 2x2 system of equations, if a false statement is produced during the substitution or elimination method, then there is no solution to the system. So keep an eye out for statements such as 0 is equal to 9, 1 is equal to 4, 7 is equal to -3. If you hit such a point, that lets you know that the visual representation of what you are working on looks something like this. You have two parallel lines, and the area of solutions do not overlap each other. Now let's walk through an example. Find the solutions by graphing the system of inequalities. Inequality A, we have x plus y is greater than 3. Inequality B, we have x minus y is less than or equal to 2. So how do we find the area of solutions? So step 1, isolate y on the left side of each inequality. So we'll first take a look at inequality A. X plus y is greater than 3. We want to isolate y on this side, so we'll subtract x from both sides, leaving us with y is greater than negative x plus 3. So we'll change inequality A to y is greater than negative x plus 3. You'll see why we do this in a second. It'll make it much easier to draw the lines that these expressions represent and to find the area of solutions. So this expression here, y is greater than negative x plus 3, is equivalent or the same as x plus y is greater than 3. So we'll change this expression to this expression. We'll now repeat that process for inequality B. X minus y is less than or equal to 2. We'll start by subtracting x from both sides, leaving us with negative y is less than or equal to negative x plus 2. And now to negate the coefficient negative 1, you'll want to divide both sides by negative 1. When you divide or multiply both sides of an inequality by a negative number, you'll want to reverse the inequality. So we switch it from less than to greater than. When we divide both sides by negative 1, we get negative y divided by negative 1 is y. We reverse less than to greater than and keep the equal to. Negative x divided by negative 1 is x. And positive 2 divided by negative 1 is negative 2. So inequality B, x minus y is less than or equal to 2, is equivalent to y is greater than or equal to x minus 2. So we'll switch this inequality with this one. This will make it easier now for us to figure out a few points on each line for these inequalities, and then use our greater than and greater than or equal to inequality signs to figure out what lines these expressions represent and the solutions for each expression. So step 2, we want to change inequality A to an equation. So we simply change this greater than sign to an equal sign. And now we have the line that represents that inequality. Y is equal to negative x plus 3. In step 3, we can record 3 xy values for equation A in a value table. So since we'll be sketching these lines in a coordinate plane, I am always going to use negative 1, 0, and 1 for our x values whenever possible. That way we get the points closest to the origin and sketch our lines closest to there. So for this line, y is equal to negative x plus 3. We'll plug in negative 1 for x and see what our y value becomes. So y is equal to negative 1 times negative 1 plus 3. Negative 1 times negative 1 is positive 1. 1 plus 3 would give us 4. So along this line, when x is negative 1, y is 4. So that's 1 point on that line. We repeat this for where x is 0. Negative 1 times 0 is 0. Plus 3 would give us 3 for our y. So when x is 0, y is 3. So 0, 3 is another coordinate on this line. And now we find one more point along this line when the x coordinate is 1, giving us y is equal to negative 1 times 1, which is negative 1. Negative 1 plus 3 would give us positive 2. So 1, 2 is a third coordinate along this line. So now we'll put this value table to the side and repeat this process for inequality B so that we're able to sketch this line as well. So step 4, change inequality B to an equation. So we change our inequality sign to an equal sign. And now step 5, we want to record 3 xy values for equation B in a value table. We'll plug in -1, 0, and +1 for x, and then we'll record the resulting y value. So when x is -1, we get y is equal to -1 minus 2, which is equal to -3. So when x is -1, y is -3. And now we plug in x is equal to 0. Y is equal to 0 minus 2, which should be equal to -2. So when x is equal to 0, y is equal to -2. And now for our third point, we'll plug in +1 for x, giving us y is equal to 1 minus 2, which is equal to -1. So 1, -1 is a third point on this line. And now for each inequality, we have 3 points along the line for the inequality. And we have the inequality signs that will let us know whether it's the points above or below those lines that are solutions to the inequality. But before we begin sketching these inequalities, we first want to find the point where these two lines intersect. So this is now where we'll use the substitution and/or elimination methods to find the vertex. So step 6, we want to add the equations together. When we do so, we have equation A is y is equal to -x plus 3. And inequality B becomes equation B, y is equal to x minus 2. If we add the two equations together, we're able to eliminate our x and to find the y value for this vertex where the two lines intersect, giving us y plus y, which is equal to 2y. -x plus x cancel each other out. And 3 plus -2 is equal to 3 minus 2, which is 1. Now to negate this coefficient of 2, you can divide both sides by 2, leaving you with y is equal to 1 divided by 2, which is equal to 1/2, or 0.5. And now that we've found the y value for the vertex, we can now substitute y into either equation A or B, and then solve for x. So if you plug it into equation A here, you'll get 0.5, 1/2, is equal to -x plus 3. And now you'll subtract 3 from both sides. 1/2 minus 3 would give you -2.5, or -2.5, is equal to -x. You'll divide both sides by -1, leaving you with x is equal to -2.5 divided by -1, which is +2.5. So you get x is equal to 2.5 when you plug in y is equal to 1/2 into equation A. If you chose to plug it into equation B, you would get x is equal to 2.5 as well. So 0.5 is equal to x minus 2. So you'll start by adding 2 to both sides, leaving you with x is equal to 1/2 plus 2, which is 2.5. So we see that the vertex for inequality A and B is 2.5, 1/2. So now that we know the vertex and we've created value tables with 3 points for each line, we can now plot the vertex and sketch both lines. So step 10, we want to plot the vertex, the point where the two lines cross, +2.5 along the x and +1/2 along the y. So you sketch out a coordinate plane and you plot the point at 2.5 along the x and +1/2 along the y. And now you go back to the value table you created for equation A. In step 11, you plot the points from the value table in the coordinate plane. So the first point is -1 along the x and +4 along the y. The next point is 0, 3, and the third point is +1, +2. So now that we have the points that will allow us to sketch equation A, Step 12, draw a dotted line through the points to create equation A or line A. And it is dotted since in our inequality is greater than but not equal to. But before we shade the area that represents the solutions for inequality A, we're next going to sketch the line for equation B. So step 13, plot the points from the value table of equation B. So the first point is -1, -3. So you go to your coordinate plane and plot the point. The next point is 0, -2. So you plot the point. And the third point is +1, -1. Plot the point. And now you have the 3 points that will allow you to sketch equation B onto the coordinate plane. So step 14, draw a line through the points. And it is a solid line since inequality B is greater than or equal to. So the solutions are included on the line. In inequality A, they are not included along the line. And now that we have the sketch for both lines, we can now shade the areas that represent the solutions for each individual inequality. We want to shade the area above, greater than, above inequality A. So you go to the line for equation A and you shade the area above that line. And now for our second line, step 16, we shade the area above inequality B. So you go to the line for equation B, greater than is above it, so you shade the area above that line. So above inequality A and above inequality B would be this area right here. And then the solutions would continue, making this an unbounded or open system. So that is how you would go about finding the solutions to a 2x2 system of inequalities by graphing the inequalities. Let's now have you try a few practice questions. Find the solutions by graphing the system of inequalities. Question number 1, inequality A, 2x minus 5y is greater than 10. In inequality B, x is greater than 3. Question number 2, inequality A is -x plus y is less than 3. Inequality B is 2x plus y is less than 0. In question number 3, inequality A is 4x plus y is less than 3. And inequality B is y is greater than 2x plus 6. Pause the video. Answer these questions, and then press play when you are ready to begin. Question number 1. Inequality A, we have 2x minus 5y is greater than or equal to 10. In inequality B, x is greater than 3. So since we only have one variable here, step 1 will isolate y on the left side of inequality A, since we won't have to do it for B here, there's no y. So 2x minus 5y, we'll start by subtracting 2x from both sides, leaving us with -5y is greater than or equal to -2x plus 10. To cancel out this coefficient of -5, we'll divide both sides by -5. And since we're dividing by a negative number, we'll reverse the greater than to less than, leaving us with y is less than or equal to. -2 divided by -5 would give us +2 over 5. We have 2x, so it's 2x over 5. 10 divided by -5 is equal to -2. And it'll make it easier when we're plugging in values for x if we change this fraction to decimal form. 2 divided by 5 is equivalent to 0.4. So we'll rewrite inequality A as that. So now, step 2, change inequality A to an equation. This way we can find 3 points along the line. So we get y is equal to 0.4x minus 2. In step 3, record 3 xy values for equation A in a value table. So we'll plug in -1, 0, and 1 for x and record the corresponding y values. So when x is -1, we get 0.4 times -1, which is -0.4 minus 2. -0.4 minus 2 is -2.4. So when x is -1, y is equal to -2.4. So that's the first point in our value table here. Now we'll plug in x is equal to 0, and that would give us 0.4 times 0, which is 0. 0 minus 2 is equal to -2. So our second point, x is 0, y is -2. And now we'll plug in 1 for x, giving us 0.4 times 1, which is 0.4, minus 2. 0.4 minus 2 is equal to -1.6. So when x is +1, y is -1.6. So now that we have 3 points for equation A, we can create a value table for equation B. So step 4, change inequality B to an equation. So we change the inequality sign to an equal sign, giving us x is equal to 3. So in our value table, all of the x values will be 3. So we won't be changing the x from -1 to 0 to 1. So instead, we'll change our y to -1, 0, and 1. So our value table for equation B is 3, -1, 3, 0, and 3, +1. So this would be a straight vertical line going up and down, where x is equal to 3 on the x-axis. So now that we have our value tables, we'll be able to sketch the lines for each inequality, but we first want to find the vertex where these two lines cross. So step 6, substitute x into equation A. So equation B is x is equal to 3. So since we know this, we can plug that in to A here, giving us y is equal to 0.4 times 3, which would be 1.2, minus 2 would give us -0.8 as our y coordinate for the vertex. And now that we know the y value, we know the vertex for A and B is where x is 3. Since that's the only x value where this line exists, it's a straight line up and down where x is 3. And it crosses at -0.8. So we have the vertex where the two lines cross, and we have value tables for each line, which will allow us to sketch each line. So now, step 8, we want to plot the vertex at 3, -0.8. So we go to 3 along the x-axis and down to -0.8. We plot the point. And now step 9, plot the points from the value table of equation A that we did a moment ago. So the first point is -1, -2.4. So we plot the point. The second point is 0, -2. Plot the point. The third value is 1, -1.6. So we plot the point. And now we have the 3 points that will allow us to sketch this line here. So step 10, draw a line through the points. And it's a line, since we have less than or equal to. The equal to lets us know that it should be a solid line instead of a dotted line. So this line is for inequality A. Now let's repeat the process for B. So step 11, plot the points from the value table of equation B. So we plot the 3 points. So the first one is 3, -1. The second one is 3, 0. And the third point is 3, +1. And now with these 3 points, we'll be able to sketch our line for B. So step 12, draw a dotted line through the points. So now we have the 2 lines for each inequality. So now we just need to shade in our area. So step 13, shade the area below inequality A. It's below since our inequality sign is less than. So we shade in the area below the line for A. And now step 14, shade the area to the right of inequality B. It's a straight line up and down, and it's greater than. On the x-axis, the values go from 3 to 4 to 5 to 6 and so on. So they get greater to the right. So we shade the points to the right. And when we do so, we see the overlapping area below A and to the right of B is here. So this would be the answer to question number 1. So let's have a look at question number 2. Inequality A, negative x plus y is less than or equal to 3. Inequality B, 2x plus y is less than 0. So step 1, isolate y on the left side of each inequality. So starting with A, we want to add x to both sides, giving us y is less than or equal to x plus 3. So we'll rewrite inequality A with this expression. And now we'll rearrange inequality B. So since we want to isolate y on the left, we'll start by subtracting 2x from both sides, leaving us with y is less than negative 2x plus 0, which is the same as negative 2x. So we rewrite inequality B with y is less than negative 2x. And now we can create value tables for each line and then sketch each line. Step 2, change inequality A to an equation. So we change less than or equal to an equal sign. And now we want to plug in negative 1, 0, and positive 1 for x, and then write down the corresponding y values. So when x is negative 1, we get y is equal to negative 1 plus 3, which is positive 2. So that's the first point in this value table. X is negative 1, y is 2. We then plug in 0 for x, giving us y is equal to 0 plus 3, which is equal to 3. So that becomes the second point in the value table for equation A. And now we plug in positive 1 for x, giving us y is equal to 1 plus 3, which is 4. So the third point in this value table is x is 1, y is 4. And now we want to repeat this process for B. So step 4, change inequality B to an equation. So you change the less than sign to an equal sign, giving us y is equal to negative 2x. And now step 5, record 3 xy values for equation B in a value table. So we first plug in negative 1 for x, and we get y is equal to negative 2 times negative 1, which is positive 2. So the first point in the value table is negative 1, 2. We then plug in 0 for x, giving us y is equal to negative 2 times 0, which is 0. So when x is 0, y is 0. And now we plug in positive 1 for x. And when x is 1, we get y is equal to negative 2 times 1, which is negative 2. So 1, negative 2 is the third point in this value table. And now we can find the vertex where these two lines cross. So we'll write out both equations. Y is equal to x plus 3, and y is equal to negative 2x. And since we cannot eliminate the x's by adding or subtracting these two, we'll focus on the y's. And since we have y and y, if we subtract equation B from equation A, we'll cancel out our y's. So we'll solve for x first. So y minus y gives us 0. X minus negative 2 is x plus positive 2x, which gives us positive 3x, plus 3, or 3 minus 0 is 3. So now step 7, solve for x. So we want to subtract 3 from both sides, giving us negative 3 is equal to 3x. So we divide both sides by 3, and that gives us x is equal to negative 3 divided by 3, which is negative 1. So now that we've found the x value, we can now substitute x into either equation A or B to solve for y. So we'll start by plugging it into equation A in case that's the one you chose. So you get y is equal to negative 1 plus 3, which is equal to 2. So the vertex is where x is -1 and y is 2. Also could have plugged in -1 to equation B, and that would also give you y is equal to +2. -2 times -1 gives you 2. So the vertex for A and B is where x is -1 and y is 2. So now that we know the vertex, we can plot the vertex where x is -1 and y is +2 in a coordinate plane. So we plot the point. And now, step 11, we plot the points from the value table of equation A. So you go back to that value table in your notes. And our first point is -1, 2. So it's the same as the vertex. The second point is 0, +3. And the third point is +1, +4. So now that we've plot the points, we can see where the sketch for this line will be. So step 12, draw a line through the points. So this is the line for inequality A. And it's a solid line since it's or equal to. Step 13, plot the points from the value table of equation B. So you go back to that value table in your notes. The first point is the vertex, -1, +2. The second point is the origin, 0, 0. And the third point is +1, -2. So these 3 points allow us to draw the line for inequality B. So step 14, draw a dotted line through the points. So now we have the 2 lines for our inequalities. Now step 15, shade the area below inequality A. We're shading the area below since its y is less than. So it's the points below that line. So we shade that area. And now step 16, shade the area below inequality B. We're shading the area below that line since it's less than as well. So we shade those points in. And we see the overlapping area, or the area of solutions, are the points between the lines here. So the solutions for question number 2 would be these. So that is the answer to question number 2. Let's now have a look at question number 3. Inequality A, we have 4x plus y is less than 3. Inequality B, we have y is greater than 2x plus 6. Step 1, isolate y on the left side of inequality A. We won't have to do anything to B since we already have y by itself on the left side. So for A, we want to subtract 4x from both sides, giving us y is less than -4x plus 3. So we'll rewrite inequality A this way instead. And now we can create value tables for A and B. So step 2, change inequality A to an equation. So we change the inequality sign to an equal sign. And now step 3, record 3 xy values for equation A in a value table. So when x is -1, y is -4 times -1, which is +4. 4 plus 3 is equal to 7. So when x is -1, y is 7. We then plug in 0 for x, giving us -4 times 0, which is 0. 0 plus 3 is equal to 3. So the second point in the value table is 0, 3. The third point, when x is +1, y is equal to -4 times 1, which is -4. -4 plus 3 is -1. So when x is 1, y is -1. So this is our value table for A, and we repeat the process for B. So step 4, change inequality B to an equation. In step 5, record 3 xy values for equation B in a value table. So when x is -1, y is equal to 2 times -1, which is -2. -2 plus 6 is +4. So the first point is x is -1, y is 4. Our second point, where x is 0, we get y is equal to 2 times 0, which is 0. 0 plus 6 is equal to 6. So our second point in this value table is where x is 0 and y is 6. And now for our third point, we plug in x is positive 1, showing us y is equal to 2 times 1, which is 2, plus 6 would give us y is equal to 8. So when x is 1, y is equal to 8. And now we have a value table for both a and b. So now we want to find the vertex where these two lines cross. So we write the equations for both a and b. And since our x's cannot cancel each other out by adding or subtracting the equation, we'll focus on canceling out our y's. We can do y minus y to cancel out our y's. So step 6 is to subtract equation b from equation a, giving us y minus y, which is 0. Negative 4x minus 2x gives us negative 6x. And 3 minus 6 equals negative 3. And now that we've gotten rid of our y variable, we can solve for the x. So we'll start by adding 3 to both sides, giving us 3 is equal to negative 6x. To get rid of the coefficient, negative 6, we can divide both sides by negative 6, giving us x is equal to 3 divided by negative 6, which is x is equal to negative 1/2, or negative 0.5. So this is the x coordinate for the vertex. So now step 8, we can substitute this x value into either equation A or B. And then step 9, we can solve for the y coordinate of the vertex. So if we plugged in x into equation A, we would get negative 4 times negative 1/2, which is positive 2. 2 plus 3 is equal to 5. So we see y is equal to 5. Or you could have plugged in negative 1/2 into b, and we get y is equal to 5 as well. So 2 times negative 1/2 is negative 1, plus 6 would give you y is equal to 5. So in either case, we see that the vertex of a and b is where x is negative 1/2 and y is positive 5. So now that we know the vertex and we have the value tables for a and b, step 10, we want to plot the vertex. So we'll go to negative 1/2 along the x and up to positive 5 along the y. And then we plot the point. Step 11, plot the points from the value table of equation A. So go back to the value table for A in your notes. And the first point is negative 1, 7. Plot the point. The second point is 0, 3. Plot the point. And the third point is positive 1, negative 1. Plot the point. And with these 3 points now, we can now sketch A. So step 12, draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we want to repeat this for B. So step 13, plot the points from the value table of equation B. The first point is negative 1, 4. The second point is 0, 6. And the third point is 1, 8. And now with these 3 points, we can sketch B. So step 14, draw a dotted line through the points. And it's dotted since it's greater than but not equal to. And now that we have the lines for both A and B, step 15, shade the area below inequality A. We're shading the area below since we have less than. So we go to A and shade the points to the left or below that line. And now step 16, shade the area above inequality B since we have greater than. So you go to B, sketch the points above. Here we see the overlapping area, or the area of solutions, are the points between the lines here. So this would be the answer to question number 3.